Today's lesson is SP8.2 and we're talking about probability of independent events. So what that means is, if it's considered to be an independent event, it means two events are independent when one event does not affect the other event. So when we have two events, and I'll explain what events are here right away, A and B, and they're independent, the probability of both occurring is P times A and B. Okay, and we can split this into a formula that goes P, A will be whatever that event is, and B will be whatever that event is. Now, when we're talking of events, it could be rolling dice, flipping coins, spinners, drawing things out of a bag or drawer, objects. You'll see as we go through this lesson. First one we're going to try is this. Okay, so a dresser drawer contains one pair of socks with each of the following colors: blue, brown, red, white, and black. Each pair is folded together in a matching set. So you reach into the sock drawer and choose a pair of socks without looking. You replace this pair and then choose another pair of socks. So they want to know, what's the probability that you'll choose the red pair of socks both times? What happens here? So we have the probability of drawing a red sock both times. And the chances of that are 1 in 5 because there's 5 pairs. And it's 1 in 5 both times because you put that first pair back, right? So we're going to multiply those together. We're back to our fractions unit where you're multiplying fractions, tops by tops, bottoms by bottoms. And you're going to get 1 over 25, which means the chances or probability that you'll choose a red pair of socks both times are 1 in 25. Not great odds. Okay, let's do another one here. A coin is tossed and a single-sided die is rolled. Find the probability of landing on the head side of the coin and rolling a 2 on the die. So we've got probability of heads and probability of a 2. Okay, so now we're going to look what the probability of rolling a head is, or flipping a head. So obviously one of 2 chances, right? It's either heads or tails. And the probability of rolling a 2 is 1 of 6, right? Because there's 6 sides to a die. Alright, multiply those together and we get 1 over 12. So the probability of doing both these things at the same time is once out of every 12 tries. And again, this isn't written in stone. You could do this 100 times and this wouldn't happen, but that's your probability answer. A card's chosen at random from a deck of 52 cards. It's then replaced and a second card is chosen. What's the probability of choosing a jack and then an 8? Okay, so this, hopefully you are going to think, oh, these odds are going to be high. Okay, so let's go probability of a jack, probability of an 8. Okay, so there's 4 jacks out of 52 cards, no jokers. 4 8s out of 52 cards. If you multiply tops and tops, bottoms and bottoms, you get 16 over 2707. This is not your final answer. This reduces. If you're going to do it this way, you have to be able to see that. And it actually reduces to 1 over 169. My suggestion is to do some reducing before you multiply, thinking back again to our fractions unit. So let's look on the diagonal here. 4 goes into 52 13 times. So these can be reduced, as can these. Okay, then we do tops and tops, bottoms and bottoms, and we get that 169 right away. I suggest doing this so that you don't miss the fact that this can be reduced, because this one, when it ends in an even number and an odd number, sometimes people think, oh, I'm done, this can't go any lower. Okay, so now we can see the probability is 1 out of 169 tries. Okay, and those are pretty high odds. Let's do the next one here. A jar contains 3 red, 5 green, 2 blue, and 6 yellow marbles. My picture isn't actually these numbers. A marble is chosen at random from the jar. After replacing it, a second marble is chosen. What's the probability of choosing a green and then a yellow marble? All right, here we go. Okay, so let's add them up first. So we've got 6, 7, 8, 11. We've got 16 marbles total. Again, my picture isn't representing these numbers, and it won't always. So, okay, probability of green, they're saying, and then a probability of drawing a yellow. So, green, they said there's 5, and I just said there's 16 total. Yellow, they're telling us there's 6 of the 16. Again, look to reduce here, which I can. So this is going to be a 3 because I'm just going to divide them both by 2, right? Okay, then I've got 5 times 3 is 15. 8 times 16 is 128. I know that's my lowest. Okay, so the chances, probability of choosing a green and then a yellow are 15 out of 128 tries. Okay, and that's just how this goes for probability of independent events. Okay, so each of the experiments in the last four slides involved just 2 independent events that occurred in a sequence. So in some cases there was replacement of the first item before choosing the second. This was needed in order to make the 2 events independent. So what happens if we have 3 independent events? All you do is add on one more piece to the puzzle. Okay, so this is what we had before. Now we're going to add 3, and we'll just multiply by the probability of the 3rd event. And I'll do one question like that, and it says, what's the probability of spinning orange, rolling 6, and landing on the tail side of the coin? Alright, so probability of spinning orange, there's 4 chances to do that right here. So, actually, let's do this first. This isn't a bad idea. Probability of spinning orange, probability of rolling a 6, and probability of a tail. Okay, so orange is 1 of 4 chances, right? Times, we want to roll 6, 1 of 6 chances because there's 6 sides to the dice, and probability of a tail is 1 of 2. So we're going to multiply all those together, and our chances are 1 in 48 that this is going to happen. Okay, I actually added some interactive tools here, and let's just see. I'm going to spin twice, and I'm going to do the dice twice. The coin doesn't flip. Let's just see. 1 in 48 chance. Am I lucky? I have a feeling I'm not going to be. Nope. One more chance. Ooh. That die didn't work, but I couldn't flip the coin either, right? But you can see where this is coming from. And the chances are pretty high that it's actually going to happen. Alright, so that's really all there is to this portion of your lesson, and you should be good to go for the assignment. I'll see you in the next one.